This is where we're going to begin. Okay, this is a standard that you've already done, and you were assessed on last week, finding products. Okay, now, when we did products, we did a monomial times a trinomial, we did a binomial, and we did a trinomial and a binomial. Okay, these are all examples of binomials times binomials. How many multiplications should be happening when you multiply a binomial and a binomial? 4. What acronym, favorite 4-letter F word do we use for that multiplication? We use FOIL. Who remembers what FOIL represents? First, outside, inside, and last. Okay? Let's look and see how that looks in problem number 1. When we multiply our first terms together, x times x is x squared. When we multiply our outside terms together, x times 6 is 6x. When we multiply our inside terms together, 5 times x is 5x. And when we multiply our last terms together, 5 times 6 is equal to 30. Now, it's not our final answer because what do we still need to do? You need to combine your like terms, okay? And our like terms right here would be our positive 6x and our positive 5x. Now, remember, when we multiply, we change exponents. But when we add and subtract, we don't do. Okay? So when we go to rewrite this into standard form, we're going to have x squared plus 11x plus 30. Okay? Now, here's what I'm going to tell you, just so you can kind of get into this train of thought today. What we're doing today when we factor is you're going to be given an answer to the problem, and you're going to need to figure out what it started with as a multiplication problem. You're going backwards. Okay? So we've spent several days multiplying to find that trinomial answer. Okay? Today we're going to take that trinomial answer and we're going to work our way backwards into the two different binomials. That's the second type of factoring we're going to talk about. Okay? Question. That's what they're going to give you, and then we're going to work our way backwards. But yes, that is our final answer for that problem. Okay? All right. Same thing in problem number 2. Okay? Multiply your first terms together. X times x is going to be x squared. X times 3 is going to be 3x. Negative 7 times x is negative 7x. And negative 7 times 3 is negative 21. Just like in the previous problem, you should be able to go ahead and combine your like terms here. And you're going to be left with x squared minus 4x minus 21 as the final answer. Okay, and then we get to problem number 3. X times x is x squared. X times negative 6x is, negative 6 is negative 6x. Negative 8 times x is negative 8x. And negative 8 times negative 6 is a positive 48. Combining together our two middle terms here, we have x squared minus 14x plus 48. Now, here's what I want to do today. This is why we're starting with this. Okay? First of all, I want to show you how we're going to undo what we've been doing. This is what we've been doing. We've been foiling it out, combining like terms, and getting to this. But what I really want to start to emphasize today is this. Take a look at the final answer for each of these 3 problems and tell me how it is at all related to what we started with. And I'm not going to give you any more direction than that because I don't want to lead you to water. I want you to look at it. So take a look at the answer to problem number 1. Specifically the numbers that are in the problem. And then look at how we started. Same thing in number 2. Same thing in number 3. There are 2 things I'm hoping you're going to recognize. I want to see if we can figure that out without me telling you. And here's the thing. When we're finding a pattern, you can't tell me that it's worked in the first one but doesn't work in the second 2. Whatever pattern you're telling me works, it works in all of them. you can only talk about one of them.
Okay. Will the numbers in the first column, if we multiply them together, obviously you're going to get 30. And then if we add them together.
Oh, no. Boop, 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 boop. Don't go that far. All right, so everybody take a look at problem number 1. Other than the ones that are in front of the x's, the two numbers that appear in that problem are 5 and 6. And when you multiply 5 and 6 together, you get what? You get 30. And if you move to problem number 2, those two numbers are negative 7 and 3. And when you multiply those together, what do you get? Negative 21, which is also part of our answer. And in problem number 4, when you take negative 8 and negative 6 and you multiply those together, you get positive 48. Now, Carly said obviously because that's literally what we did, wasn't it? That was the L of FOIL, correct? All right, now, she almost had too big a mouth and said the second one. Does somebody else, sorry, Carly, recognize the other pattern that I want you to recognize? Miles.
If you add or subtract the numbers in it, it also equals the outside.
Okay,
Yeah.
so your middle number. So if you take a look at problem number 1, what happens when you add 5 and 6? You get 11. Look at the middle number there, ladies and gentlemen. Ooh, pretty cool, isn't it? Then when you take negative 7 and 3 and you add those together, guess what you get? Negative 4. We almost have a pattern going on here. And then finally we take negative 6 and negative 8 and we add those together and we get negative 14. It's like it's magic. So, there is a direct relationship between how the problem started and how the problem ended, isn't there? So, do you think we could use that relationship to work our way backwards? Probably. Now, I'm going to ask you then, before I start teaching the actual lesson, think about this then. If I've already told you what our goal is, it's to go backwards. What do we think would happen, or the answer would be, I should say, if I gave you that problem? And I said, I'd like to know how we're going to start out this. I'd like to factor this expression. Using the pattern that both Carly and Miles just described, who thinks they know what the answer would be? Carly. Nope, you're close. Not quite though. Because if I took 4 and negative 5, right, those would multiply to give me negative 20. I need to get a positive 20. No. Any thoughts? I'm not taking you to the water and forcing you to drink, but like, this will all come together if you start to actually think here a little bit, rather than being like, he's just going to tell us in a few minutes anyways. That's not learning, that's just being told what to do. Carly, re-explain your pattern. The two numbers we're looking for in the 3 problems that we did before, the 2 numbers you were looking for, you said always did what? No, that's not the pattern. You multiply them together to get this number, right? Miles, what pattern did you describe? If you added them, you got this. Man, it's almost like we've been doing problems like this year, where I ask you to find 2 numbers that multiply to give you a number and add to give you a number, right? Oh yeah, because we have for like 3 weeks. Right? This is why, ladies and gentlemen, I need to start thinking like that. What are 2 numbers that are going to multiply to give you 20, positive 20, And they're going to add to give you negative 9. Negative 4 and negative 5. So as a result, this is going to be x minus 4 and x minus 5. You had the right two numbers, the signs were incorrect though. This is what we're doing. Now, here's the beauty of it. It's boiled down to that same topic, the same question that I've been asking you for quite some time. Our openers for almost over a week were devoted to find two numbers that multiply to give me this and add to give me this, right? Remember doing that, hopefully? That's exactly what you're doing here, isn't it? Find two numbers that multiply to give me 20 and add to give me negative 9. Now, it would be absolutely wonderful if it was always this easy. But it's not going to be. Okay? So before we leave for lunch, I want to show you the downfall of that. Like, this pattern's not always going to work. The pattern that Carly and Miles just described will not always work. Okay? So, last thing I want you to do, another multiplication problem. I want you to take 5x plus 2, and I want you to multiply this by 4x plus 3. Okay, FOIL that out and see what we get for an answer here. I want to wrap this conversation up before we leave for lunch, so when we come back we can actually dive right into the material. Is that what we got? Now, does the pattern that Carly and Miles described still work here? No. One thing still works. 2 times 3 is still 6. But 2 plus 3 is not obviously 23. So, we want to come up with a strategy that works both here and here. And that's the big goal that I've got for the next couple of days. I want you to be able to do it when it's easy and also when it's not easy to identify. And so what we're going to talk about when we return from lunch is one method that I do for all factoring problems that include greatest common factors. We're going to put it all together today, ladies and gentlemen, and we're going to add layers of complexity each day as we go. Carly, question? Not necessarily. Nope. All right, we'll pick this back up after lunch.